So, atomic orbitals present in metals, they form bonding orbitals and anti-bonding orbitals. Bonding orbitals, lower charge orbitals, and anti-bonding orbitals, higher charge orbitals. So, conductivity in metals here. So, this is valence bond having partly filled electrons. Okay, and this is conduction bond. Conduction band. So, in metals, both gets overlaps like this. That's why electrons flow into the conduction bond. Due to this, metals are good conductors of electricity. Okay. So, here conductivity range is in between 10 to the power of 3 to 10 to the power of 8 per ohm per centimeter. Okay. Whereas in insulators, this is valence bond and this is conduction bond. And in between these two, large energy gap is there. That's why electrons does not easily flows into conduction band. Okay. So that's why here insulators are very poor conductors of electricity. And their conductivity ranging is in between 10 to the power of minus 22 to 10 to the power of minus 10 per ohm per centimeter. Whereas coming to semiconductors, here also valence bond and a conduction band. Okay. So, in between these two bands, small energy gap is there. That's why electrons may easily enters into the conduction band. Okay. So, conductivity ranging in semiconductors, that is in between 10 to the power of minus 6 to 10 to the power of 4 per ohm per centimeter. Okay. Then coming to semiconductors. Semiconductors. Solid semiconductors. Next, semiconductors. So, generally semiconductors are used in solar cells. Okay. And pure silicon. So, pure silicon and pure germanium, they are intrinsic semiconductors. Okay. So, semiconductors are formed by the addition of impurity to the pure element. Okay. So, that addition of impurity to the pure element, that phenomena is called as doping process. Through doping process, we get two types of semiconductors. Okay. One is N-type semiconductors. N-type semiconductors. So, if you take silicon, silicon belongs to fourth group. If a silicon gets doped with 50A group element, for example, silicon is doped with 50A group element arsenic, we get N-type semiconductor. Okay. So, here arsenic acts like impurity. Okay. So, addition of impurity to increase the conductivity of the substance, that is called as doping. Okay. So, what is doping? Semiconductors are formed by doping process. So, doping is addition of impurity to the substance to increase its conductivity. Okay. So, addition of impurity to increase conductivity of substance. So, that is doping process. So, with the doping process, we get two types of conductors. First, N-type. So, here impurity is arsenic. So, silicon belongs to 4th A group. Arsenic belongs to 5th A group. Okay. Number of valence electrons present in silicon is 4 and arsenic is 5. Okay. For example, this is lattice of silicon. So, all these are silicon atoms. Okay. and each silicon atom gets surrounded by 4 electrons. So valency electrons, and it forms bonds with the nearest neighboring electrons. Okay. So here in silicon, so all these are silicon atoms. If silicon gets doped with arsenic, okay, arsenic belongs to 50A group and it contains 5 valency electrons, whereas silicon contains 4 valency electrons. Okay. If arsenic occupies one of the atom of silicon, here it forms 4 bonds with the nearest 4 silicon atoms and it contains 1 more valency electron. So that excess of electron, that is, occupies the interstitial position like this. So electron, this is electron having negative charge. So here movement of electrons which are present in the gaps between silicon atoms. So they are responsible for the conductivity. So here conductivity is due to the negatively charged electrons. That's why this type of semiconductors are called N-type semiconductors. Okay. Then coming to P-type semiconductors. Next, P-type semiconductors. So P-type semiconductors, these are also formed due to doping process. So here silicon doped with 3rd A group element, for example boron. It gets doped with 3rd A group element, boron. So silicon contains 4 valency electrons and boron contains 3 valency electrons. Okay. And here also this is lattice of silicon having silicon atoms. Okay. If silicon gets doped with the boron, one of the lattice point that is occupied by boron. Okay. But boron contains only 3 valency electrons. That's why it forms only 3 bonds with the nearest neighboring atoms. And one is remains as positive hole. So that is a positive hole. No electron is present here. Okay. No electron. And conductivity of this type of semiconductors, that is due to the presence of empty space or positive hole. Okay. So conductivity through positive hole. That's why this type of semiconductors are called P-type semiconductors. Okay. So whereas N-type semiconductors, conductivity is due to negative electron. That's why they are called N-type semiconductors. And P-type semiconductors, conductivity is due to positively charged hole. That's why this is called P-type semiconductor. Okay. So 2 types of semiconductors. And both are formed due to doping process. Okay.